Good morning. My name is Pascal Bush. I'm going to present you the company Arabelle Solutions, and Suman Ray will continue to present you SMR solutions for Darlington. Thank you for being here. We are going to introduce you the company Arabelle Solutions. So basically, Arabelle Solutions is a company that delivers steam turbine, generator, all equipment for turbine hull in a nuclear power plant. Today, about 1/3 of the global nuclear base in the world is Arabelle Solutions equipment. We have a portfolio ranging from 50 megawatt to 1900 megawatt, 1900 megawatt being amongst the biggest steam turbine in the world. We have annually about 100 units service. We make a lot of service worldwide as well. And today we are going to show you more precisely our solutions for SMR applications. Arabelle Solutions has a footprint worldwide. We see here our presence. We have more than 3,500 employees worldwide in 16 countries. We have 5 factories and workshops, hundreds of engineers, field experts, TFAs, and also we manage worldwide a supplier chain network of more than 1,300 suppliers. And I really want to insist that all these suppliers are really dedicated to nuclear safety. This is very important in Arabelle Solutions. We deliver equipment for nuclear power plants, so nuclear safety, nuclear culture is extremely important for us. Arabelle Solutions delivers all the support, all the needed support for our customer, ranging from engineering studies, equipment as standalone equipments, but of course we do EPCs on the turbine hull, water steam cycles, steam turbine generator, all the equipment of the turbine hull. We do that, we can do in EPC according to the need of the customers, full turnkey of the turbine island. This is really our expertise, and again, we do that for nuclear power plant, nuclear safety, ITNS. All these are very important in the business. This is just not just having equipment as we would have done for another type of plant. Nuclear power plant is, of course, a completely different business. I said that we do the EPC, the full turnkey. We also, of course, provide service during the warranty to our customer after the commissioning, but also all what takes care of, we take care of the lifetime maintenance of our equipment and also equipment of other companies, whether we customize the parts to change. We take care of the minor and the major outages. Emergency repairs, of course, we are here to support our customer in case of need, emergency needs. But also on the life extension of the plant, we are here during the lifetime of the plant with any service which is upgrade the equipment. That means upgrade the performance, improve the performance, optimize the performance during the lifetime, because of course the technology always evolves, and we are here to support our customer to improve the performance of a power plant during the lifetime. We also do retrofits with new equipment. It's always according to the need of the customer. We do that for any type of reactor. We are really a multi-reactor approach. We are here to support any type of technology on the reactor, whether it's EPR or other brands. Arabelle Solutions is a company that goes back to the early 1900s. That means that we have all the expertise inherited from all the companies that have been improving the steam turbine business, the steam turbine generator, and all the turbine hall equipment. It goes from BBC, Rato, and of course Alstom. Arabelle Solutions today is really the inheritage of Alstom, and Arabelle steam turbine, which are very famous on the French fleet and also in China. We have the Arabelle technology is really a unique technology to have the most powerful equipment worldwide. And today we do all the service, all the equipment dedicated to SMR application. That means that the steam turbine generator that are high output, let's say 1,000 megawatt to 1,900 megawatt, are shaft line that are called Arabelle, and also we have the shaft line that are more 50 to 7, 8, 900 megawatts, which are other shaft line, and we are going to have more details on this one. But really, what is important to keep in mind is that Arabelle Solution technology is an inheritage of more than a century of technology. Here are more details about all the equipment that we provide. Again, we do EPC of turbine hall, and when I say EPC of turbine hall, we provide our equipment on this turbine hall, whether it is the steam turbine, the generator, and also we can see the steam turbine Arabelle type, and the more let's say smaller size, more dedicated to SMR application. We provide the generator, so ranging again from 50 to 1,900 megawatt, different technology, air-cooled, hydrogen-cooled. We have the heat exchangers, MSR, the moisture separator reheater. We do also all the heater, LP, HP heater, condenser. This is all technology in-house that we manufacture in-house. Pumps, we have pumps for the feed water, cooling water pumps, extraction, vacuum pumps. All these are technology owned by Arabelle. We also provide nuclear controls. We provide cyber security. So again, we provide all the range of equipment and services for a nuclear turbine hall. Now we are going to focus more on the SMR business to show you our solution for the SMR. So we really are now creating, and we are really expert in platform for SMR, dedicated to SMR. So that means the range of 50 to more 600 megawatts. All this is related to the technology that we have inherited from the companies I showed before. So we integrate all the technologies into the turbine hall. Of course, steam turbine generator, all the heat exchanger composing the water steam cycle, automation control, all the BOP that is in the turbine hall. We take care of that, because when we say that we do turnkey solution for turbine hall, this is, of course, it integrates this equipment and all the service during the lifetime of the power plant. Again, we do new equipment and service support to our customer. One very key issue on nuclear power plant is the nuclear safety. ITNS, important to nuclear safety, is not. Arabelle Solution is a provider of equipment in a nuclear power plant, and this is extremely important also from our supplier standpoint. That means that we always ensure that our suppliers have the nuclear safety culture. This is a must when you are part of an equipment that is inside a nuclear power plant. All our engineer, all our workforce is very keen on having the nuclear safety culture, and this is extremely important for us. So now Suman will continue on the equipment.
Thank you, Pascal, and very warm welcome, and thanks for your time today on this presentation. Before I go to the steam turbine of the Darlington, I just have to mention a few words about the SMR technology itself. You know, this is quite evolving technologies. There are a lot of different purposes, and that also causes different steam parameter for the steam turbines. So we have Gen 3 plus, Gen 4, and depending upon that, we are trying to develop, or we are developing a platform which will consider a range of 50 to 600 megawatt with some common features across the platform to have the good experience feedback as well from those platforms. Now, on those 50 to 600 megawatt, if you remember, the last few decades, the fossil machines was predominantly used. That is either conventional coal plants or it's a combined cycle power plants. Those were predominant on the market. And obviously, it means people put money on optimizing those solutions in terms of performance and cost and everything. And at the same time, at that power range, the full speed solution provides a better compact footprint compared to the very large nuclear turbine, which is a half speed normally. So it was obvious for us when we start the platform, we started from a fossil platform, which was established and quite proven. And then we implement the elements from the experience of large nuclear units, because we know instead of, there is a difference in steam parameters, but apart from steam parameter, there are requirements from regulators or nuclear safety, which makes it different than the fossil turbine. So first we take the nuclear safety, and one of the examples is the missile analysis. So the turbine and the whole system should be designed such a way that the probability of the missile damage is minimum or negligible. So that has to be done. Second is reliability. Nowadays, you see the nuclear plants are asking for more and more lifetimes. So earlier, fossil maybe was designed for 30 to 40 years lifetime, but we are now aiming for 80 years lifetime and selecting the material accordingly, so that at least the static component you can keep as it is, means with minimum repair or just inspection. The third is the availability. It's quite important. Our large fleet Arabelle have an exceptional reliability record, so we want to bring that. And also would like to synchronize the maintenance cycle of the steam turbine with the refueling cycle of the reactor, so that it gets the maximum availability. Steam turbine doesn't need an additional maintenance. And then it's the improved efficiency. We take all those 3D blading technology, the aerodynamics optimization from the fossil, and incorporate into this, so that it gets the maximum efficiency on that level. So we are proud and happy that we have been announced or selected as a main equipment supplier for the Darlington, Canada project, and we're thankful to Ontario Power Generation for that. In Darlington, we will be supplying STF N200 steam turbine generator, which means a single flow HP turbine, 2 double flow LP turbines along with an air-cooled generator. And at top of it, we are also supplying all the major equipments for the conventional island, which means the condenser, moisture separator, reheater, all the feed heaters, and plus some additional drain coolers. So this is the platform definition from our side. And you see Darlington lies on the STF N200 at the very beginning of the full platform. So on this platform, it's everything, all HPs are single flow. You can use the number of LPs depending upon your cooling solutions or cooling requirements. And then it can coupled with an air-cooled generator or a hydrogen-cooled generator or a Gogiatov two-pole means mixed kind of generator. On the other side, we have on 50 to 130 megawatt range is very compact single casing machines, which is also for small like new scale or this kind of reactors is very useful. So from STF N200 to 400, it's basically a natural evolution on size. It's just a scaled modules going bigger and bigger. And STF N600 is more of an advanced kind of, so there in spite of HP and LP, there can be an IP turbine as well whenever it's required. So from the fossil platform, we kept the technologies. First will be the single bearing concept between the turbines. So two turbines sharing a common bearing. That will keep the footprint quite small, also save some cost. Then we'll be using welded rotor in the Darlington project. And the benefit of that, you can select the material as per your requirement. When there is a high risk of SCC, you can have more SCC resistant material. Where there is not required, you don't have to do that. So that is also kept. And then on advanced blading side, we use those 3D profiles. We improved upon that. We put the new generation in. Also, we did the longest LSB at the moment operating at full speed. I said at 40 inch at 3600 RPM. So in the half speed range, if you compare the largest LSB we have is in Hinkley Point Power Project, which is 75 inch. And if you compare this scale down to that it will be 96 inch. So you can imagine it's the longest really, means if you compare. And the last element is the modularization and standardization, which is quite important for the SMR. We kept that concept in. So the HP turbine goes to the site in completely assembled condition. It just needs to be aligned. LP goes in very minimum parts, 2 or 3 as per requirement, and then it can be assembled on site and aligned. Now this is not the full list, but some of the major differentiator of the changes we have done compared to the fossil machine on Darlington. First is control flow blading. The control flow blading is developed in last few years. It's over and above the 3D technology. It improves the efficiency at least by 1 to 1.5%. And then we go the new high pressure turbine with a new inlet configuration. Typically in Arabelle Solutions or legacy companies, we have used RADAX, radial axial stages there. But we now went back to a torus and an axial stage completely there in this area, and with fully optimized, because the swallowing capacity is very important for the nuclear turbine. Whereas fossil, you can just increase the flow a bit by building more cold flow. But here the thermal capacity is same, so the swallowing capacity need to be ensured. And that's why we made that change. Also, the steam condition is wet at the beginning. And so once it expands, so it goes and say this area, quite a lot of coarse droplet you will find. And it's important to prevent the erosion to take out those droplets from the flow path. So after each and every stage, there is a special features which will take the water out and out to the casing. And this is not a very new technology. This is very proven technology already used in Ringhal and other sites, but it's just reinvented for this SMR purposes and used in a different way in a smaller turbine. Then we have the optimized 40-inch rear stage. So the last stage blade is very much remains same from our legacy machines. It has a lot of experience. What we changed, the guide vanes. Guide vanes designed with a hollow suction blade with a slits for water extraction, and this water is taken from the diaphragm to the outside. And that also improves the lifetime of the last stage blade. Then we have last stage blade shroud shapes. It's a patented technology. It's going under patent, so we cannot disclose much, but that will give more lifetime to the last stage blade again and prevent the leading edge erosion as well as trailing edge erosions. And of course, the L-2 blades, and those are the blades which are a bit heavy. Those are specifically optimized for the Darlington condition to keep that weight less, the centrifugal pull less, and to prevent any risk on damage due to SCC. I will take the opportunity to show our generator as well in this. So as I said, we have at least 4 types of generator for serving the entire SMR fleet. We have toe-pack generator, extremely compact, goes in a box for 50 to 130 megawatt. Then we have top air for 120 to 400 megawatt machines, MBA machines, then which is being used in Darlington, by the way. It can be pressurized or non-pressurized, depending upon the capability requirement. Then we have top gas, which is hydrogen-cooled generator. And then after top end, we have the gigatop 2-pole, which is mix of water and hydrogen-cooled. And also take the opportunity to show you the hex which we have supplied to the Darlington project. First is condenser. It's a very innovative design, and this kind of design is already put into a LifeStat project in Switzerland, and it's compared to traditional design, it's 20% more efficient. And then we have the moisture separator. It also comes with a patented technology called VARA, which means the variable amplitude across your chevron plates, and that gives a better efficiency and lower pressure drop in the MSR. Then we have the feed water heaters, and in Darlington, we implemented another patented technology from Arabelle Solutions, that is a drain cooler in the parallel circuit, which gives around 2 megawatt more to this whole power plant. So with that, I will give Pascal the opportunity to give another good news. Yes?
Yes. We announced this morning that we have sold a steam turbine generator for TerraPower Natrium SMR, which is in Wyoming, in Kemmerer, Wyoming. So it's a 550 megawatt steam turbine generator composed of a STF N600 steam turbine and a gigatop 2-poles generator, 650 MVA. So basically the shaft line length is about 42 meters. And so we have a double flow intermediate pressure module, the single flow high pressure, and 2 double flow two double flow low pressure modules as part of this steam turbine generator. So that's an announcement that is from this morning. It's we just did this with our customer, direct customer is Bechtel, with end user, of course, is TerraPower. Okay, so I thank you first to have been attending this this session, this workshop. I propose you to join us on the small room for any question that you may have. We can address any question. And again, thank you very much for your attention. I hope that you had good information and that was interesting to you.
Thank you.